Howdy. In this video, I'm going to work with Python to create a decision tree for a data set we have seen before. I already went ahead and included a couple of lines to kind of speed up the class. I am importing the pandas, matplotlib, numpy, train test split to divide the data, and reading the data set, universal bank data set. And finally, I'm gonna just look into the data set to see what is there, right? And in this data set, I see that one of the things we discussed in the class was this age was, experience was negative, and the rest of the data seems to be okay, as we did the exploratory study before. So I'm going to write a small function to fix that one and possibly any other negative values. So I start with saying that fix experience, right, and that is a value, right? And what I'm saying is that if the value is less than 0, then I'm going to return 0, right? So basically, if it is -3, I'm going to make it 0, right? I could also consider multiplying with -1 and make it positive 3, but I don't have enough information to trust that one. So I'm just going with the most basic solution I found. You can do other things as long as you can justify why you are doing it. And then if it is a positive value, then I want the code to return the value itself. So if it sees -3, then it is 0. If it is 1, then it is going to be staying as 1. Right. So let me run this line, and then I am going to do a couple of things here. First, I'm going to apply this fix experience function to this experience column, right? Let me start with that. My data frame name is bank data, right? And square bracket, column name is experience, and that's going to be equal to bank data. I'm going to apply the function I just created, lambda row for each row, fix experience, and then row experience columns, right, and then comma axis 1 for entire column, right? While here, I'm gonna do a few more things as well. ID, the index for this data set, so I would not have another index next to it. Again, we have done this before, so I'm feeling a little bit comfortable going fast through this process. If you have questions, go back and check the previous videos where we discuss all this data set in detail and this process as well. So index, and I'm gonna say the ID column name in place. Right. So I did that one. And the other thing I'm gonna do is basically education. Education is 1, 2, 3. So I'm going to introduce binary variables, but k-1, right? If there are k categories, I need k-1 binary variables for it. So let me get that one as well. This time I'm saying get dummies. Get dummies to bank data, right? And for the columns, equal to education. That is the one I need to do, and we need k minus 1, so I'm gonna say drop first. Drop first, and that is equal to true. Right. Then I'm gonna basically, if I look into this one, let me do this one. Oops. Oh, I see it. There needs to be an equal sign here. All right. And I'm gonna run from start again. Right. So ID is the index. If I look into here, there is like education 2, education 3. I'm gonna rename them with much easier names, right? And for that, I'm gonna say rename and columns basically. And that's going to be equal to curly brackets education underscore 2 is going to be graduate degrees, and then education, why don't I just copy paste this, education underscore 3 would be advanced degrees. Right, and then this is the curly bracket. I'm going to say in place basically equal to true. And one more thing I'm going to do is again we don't have a way to deal with so many zip codes. I'm gonna just drop the zip codes, and basically I'm saying that a zip code of the person is not important, at least for now, right? And let me do that one as well, and drop the, all right, and then open parentheses, zip code. Remember, this is case sensitive, right? Zip code, and then I'm going to say on axis 1, that is the column wise, and then in place true. Right. We can look into this figure again. Let me look into bank rate describe, but this is going like far too way out to the screen, so I can also do transpose it. Right. So this is kind of easier to read. I see age minimum, maximum are over there. Experience is between 0 and 43 years. Income seems to be okay. Graduate degrees and advanced degrees are here too. So at this point, basically I can start defining my x and y variables, right? Let's do the x first, and that would be basically everything but the personal loan decision. That is our category, right? I'm gonna do that one, saying that data, bank data, and then drop personal loan for axis 1, right? And my y variable is just the bank data, personal loan. right? And then I'm gonna define X train, Y train. X train, X validation, and then Y train, Y validation equal to train test splits. That is my X vars, Y var, right? And then I'm gonna use the train size of 60%, let's say, and I will have the random state of random state is equal to, let's say, 3. Oh yeah, 3. Then I can look into the X train to see if it is basically correct. Let me see. ID is there. There are some random numbers because I randomly picked. I mean, this is the order they picked. And personal loan category is not there, although it was in the main data set. And I can do the same thing to Y train, and that will be only the personal loan, right? That is here. Okay, so now I am also ready to build my decision tree, and we have a classification problem, basically whether a person will accept the personal loan or not. So from scikit-learn, right? Tree, I'm going to import decision tree classifier. Now, as we discussed in the class, we can use decision tree as a classifier or a regression for prediction purposes. Today I have a classification problem, so I'm going to use the classifier. If I was interested in predicting a value of that account or the balance of that account, then I could potentially use the regressor, right? But again, for us, it is the classifier, right? And next step is going to be building the model, then fitting to the data, right? So my decision model is decision tree classifier, right? And I'm gonna say max leaf nodes, that is how many nodes I want in the model, and let's start with only 3, right? And then now the Python decision tree knows that it needs to create 3 leaves, but it doesn't know the data. So I need to define which data the model is going to use and fit these 3 nodes. And for that, we are using X train, Y train in this order, right? So we got the results. We don't know how it looks. Perhaps visualization might be a good thing. And in order to visualize, we are going to use GraphViz, right? And again, in order to install the GraphViz, you are going to go to your command menu, command prompt, and right click to the run as administrator to avoid a couple of issues. If you don't have the right, you can still install it, and then type conda install -c GraphViz, right? And once you click, oh, I see it, -c, and then I need to add anaconda because I'm installing into GraphViz. This should work. I have the installation, so it's not going to do anything for me. But if you don't have it, it's going to install at this step, and this might take some time. Right? You just need to be patient and wait until the installation finishes. Right? So I'm gonna go back to my code, and after you install the GraphViz, you are going to import it, saying GraphViz, right? And from scikit-learn, import tree. Right, so we are going to use that one. After this is done, we are going to basically feed that decision tree to that tree graph, and then using the GraphViz, we are going to visualize it. Right, so it's going to be a couple of steps. So let's say decision tree data, that is the data I'm feeding. It's going to be tree export underscore GraphViz, right? And inside that, I'm gonna say decision model is the one I'm using it, and outfill. I don't want it to print to an out file, so I'm gonna just say, and this is none. Right. Next step is to say graph is GraphViz dot source. S needs to be capital letter, right? This decision tree data that I just defined basically in the line above, and finally I'm gonna graph it. All right, here's the result. If the x2 variable is less than or equal to 114.5, then this is the breakdown, and then if it is greater than 114.5, then I need to look into the variable x3, and if that is less than 2.5, then this is the situation, and if it is greater than 2.5, this is the case, right? But here's the problem here. It is almost impossible to figure out what is going on. I don't know. I mean, I can go find out what is the x2 and so forth. In this case, x1, x2, it seems the income needs to be 114.5 or less, then I will be here. And x3 is the family size. So I can do that, of course, figure out which variables I'm dealing with, but that is a lot of work for not much benefit. So what I'm gonna do next is define a couple of things and add the headers, like I don't know what is the decision here, make sure that is kind of easy to figure it out, and so forth. So first I'm gonna define something called target name, or target names if you want to be plural, and those are basically the labels that I'm going to use, right? One of them is the customer denies the offer, and this needs to be in the order of data, right? If 0 is denied offer, 1 is accept offer, that should follow that logic, right? And then the other one is accept offer. So next time when I see these boxes, I can see that information, right? Let me run that. And then next thing is going to be, I'm gonna look into this decision tree here, right? and add a little bit more details into it, right? So the same decision tree data, it gets the decision model that I fit based on the training data set, and start including stuff. One of them is the feature names. Oops. That is basically what is x2, what is x3, and so forth, right? And that is my x train column names, right? And then I'm gonna also include the class names. Again, class names are the classification results, whether I am doing accept, deny offer, accept offer, or if I have multiple categories, I can use that. And these class names need to be the target names, right? That I decided earlier, right? I want this boxes to be visually a little bit more appealing, so I'm gonna fill them with color. Let's say true, and perhaps round the edges, right? Again, I don't need to do this. I'm just showing you some things you could do with the graphics, right? And after this, I'm gonna oops, I made a mistake. Let me see where is that. X train, is the name correct? Invalid syntax. It says feature names x train dot columns. Oh, I forgot the comma here, right? And then I'm gonna do the same two things, basically fit this to the graphics and then visualize it. This is a little bit better, and at least this time I know x2 is the income, and based on that I'm getting these values. And initially out of 3,000 samples, almost 90% of them are denied, so entire one box is the denial box, but I can divide it based on the income, and that gets me more information, right? Based on the income 114.5, and then if I divide by the family size, I finally get to a group of customers who will accept the offer, and those group of customers are with income of greater than $114.5 thousand and family size greater than 2.5, right? And with that I get this group. There are a lot of other individuals, like over 150 in the other categories, under the other categories. Right now I'm not targeting them, so one thing I could do is perhaps add more leaf and see where can I go with that. All right, so let's add 5 leaves, right? And then I'm gonna go here and run this, right? This time, of course, I had this one initially, right? If I divide those groups a little bit more into detail, more pieces or subcategories, I realize that if I use the advanced degree, I can divide it even further, right? Those with the advanced degree, families, like income is greater than 114.5, family size is less than 2.5, but if they have advanced degree, they basically accept the offer, right? And if they don't have the advanced degree but have a graduate degree, then they also accept the offer, right? So these are my offer accepting people, so I should target them with the material I'm printing, right? So what happens if I have 20 leaves? All right, I'm gonna just build this thing. All right, so this time things are a little bit tricky, right? I mean, there's a lot of things going on this figure. If you remember, we had already caught these two categories. Now I can divide them even further. So if I go, like, say, if their income is also greater than 116.5, if they have graduate degree, and if their family size is less than 2.5, they can buy it. So that's another group. But at one point, basically creating these figures and trying to read and decide which number or what number of leaves are the best for our situation becomes really tricky and almost impossible, right? I mean, you can have a tree with basically hundreds and hundreds of leaf, and in that case visualizing is impossible. Well, I mean, seeing and understanding, perhaps the computer can do it, but understanding is a different challenge, right? So far I'm just printing or creating these figures, but as you remember, we actually make our decision based on the accuracy scores, not how good, nice a figure looks, right? So in the next step, let me go make this a little bit reasonable. Let's say 8, just for the visualization. This is good, so I can see everything on almost in one screen. And what I want to know is how I am doing in terms of accuracy scores, right? And for that, I'm going to import the accuracy scores, right? Once I have the accuracy score, then I'm gonna basically calculate the accuracy score, right? For the initially the training data set, and for the accuracy score, the parameters are basically I need to provide the true value and then the prediction, right? So I'm gonna do that. True value for the training data set is the y train, right? So that is the column that has the actual results. And then for the prediction, I'm going to say use my decision model, right, and predict this time the values inside the X train. So what it is doing is looking at the input value and then using the decision tree, this time predicting what could be the results, right? And of course, when we predict, remember, like if I'm predicting they are gonna be in this category, there are 14 people in this category, 13 of them will buy and one of them will not buy, right? But majority rules, so this category will be labeled, everybody in this category will be labeled as will buy or accept offer, right? The same way, like if I look at here, there is a majority of people are denying the offer. So although there are 13 people who could accept the offer, I'm still saying deny the offer. So I will be mislabeling these 13 individuals as deny the offer when I run this algorithm. Or when I go here and deny this category here, I will be basically mislabeling 13 people again. So it's gonna just do that and make the decision. One thing I forgot to mention earlier is that this majority rules. I think we already discussed this one in the classroom, but let's kind of touch on it again. So what I see here is a decision, deny offer or accept offer based on the majority of the observations. If the majority of observation is in the deny category, I will label it as deny offer. Now, if you look into this one, this has a higher deny, percentages in terms of total records than this one, and that's why the graph is kind of creates this lighter shade of the box, indicating that this is a deny offer, but not as strong as the other one, right? And this colors basically changes based on that intensity, how intense or what is the probability of people in that category accepting or denying the offer, right? If it seems we don't, at least my eyes cannot detect too much differences between these colors, but we could also see a lighter blue when I had let's say 12 people denying and 13 accepting. The label will be accept offer because that is the majority, but the color will be like really light blue, like this one here with the blue. All right, so now I'm ready to predict. All right, so if I just use this tree I developed, 8 I believe leaves, my accuracy score on the training data set is 98%. I can also check the validation data set. That is a easy thing. This time I'm using the X-train validation. Right. That's 97.75. That's pretty good accuracy. And they are close to each other, so I could say 8 is good. I don't know if this is the best possible number, so I'm going to basically check a couple of things, different number of leaves, and then decide what is the best.